The Milky Way galaxy is a very dynamic place. Stars don't simply orbit the galactic center, but rather move on their own in proper motion and mix with the rest of the galaxy. Take the Sun. It was once part of what is known as an open star cluster. There were once hundreds of the Sun's siblings nearby that all formed in the same cloud of gas, only to later disperse across the galaxy. Coming along with this is the presumed massive amounts of asteroids and comets that probably inhabit a majority of star systems, and in open clusters may mix, forming a class of interstellar objects, and some might even fall to Earth. There was a time, however, when this was thought to not be the case, as in a hard no, it was not possible. The early history of the study of rocks from the solar system falling to Earth as meteorites is the ultimate and incorrect science. For the whole of human history, meteorites were seen to fall, huge fireballs coming through the atmosphere that all peoples, all cultures across the Earth must have seen and taken note of. Sometimes these rocks were found, with their metal being worked by many cultures, and some stones even venerated and named for religious purposes. Sometimes these objects were known to have come from space, or at least somewhere else beyond the sky, as it were. A particularly good example of this was the Ensisheim meteorite that fell in the Alsace region in 1492, during the days when it was held by the Holy Roman Empire. In November of that year, a huge fireball was seen over much of Europe, and in the town of Ensisheim itself, a 130-kilogram rock was seen to hit the ground. Weeks later, the Holy Roman Emperor Maximilian I happened to be passing through the area and saw the recovered meteorite. He then thought it must be an anti-French sign from God, and reportedly had it chained up in a church to keep it from wandering off the way it came. It's debated among historians how true that account is, but the main mass of the meteorite is still preserved in the Ensisheim Town Hall, where it can be seen today. From the other side of the world, a very similar instance happened where a meteorite was seen to fall in Japan in the year 861 by a young boy. He led the local leadership in the town of Nogata to the impact site, where the meteorite was sitting inside a small crater. The origin of this object doesn't seem to have been a matter of debate. Rather, everyone concluded that it was a rock from the sky, and it ended up in a Shinto shrine in Nogata where it sits to this day. And after modern analysis, it's definitely a meteorite, a type L6 chondrite to be precise. The people of Nogata from the 9th century onward knew all along that they had a rock from space. But not in the West. Let me tell you a tale of a scientist who wrote a book in 1794. His name was Ernst Friedrich Chladni. He published a book which to the West was taken at the time as beyond outlandish. This was not a case of extraordinary claims requiring extraordinary evidence, but rather extraordinary claims can't possibly be true. The claim was that stone and iron masses, meteorites, could fall from the sky. If that wasn't bad enough, he claimed meteorites originated from space itself, a concept far from universally accepted at the time. The ridicule for this idea was immense from the scientific community, to the point that after the ridicule, they ignored everything Chladni did in science, including really important and since proven valid work in acoustics, and how musical instruments work in a physics context. In 1803, there was a truly huge meteorite fall in the town of L'Aigle in Normandy in France. Thousands of stones were reported to have fallen. Jean-Baptiste Biot of the French Academy went out to investigate, who had been a staunch opponent of Chladni and one of his biggest detractors. After the investigation, Biot could only conclude that rocks do indeed fall from not only the sky, but space. A few years later, in 1807, a judge in Weston, Connecticut, saw a classic meteorite fall and described the scene precisely. He saw a fireball moving from the northern horizon to almost directly overhead, where it flashed several times, which is indicative of the meteorite breaking up upon entry, and then disappeared, meaning atmospheric friction slowed it to the point that it was no longer luminous. A few moments later came the noise. He heard the detonations and roaring of the fireball, followed by a whistling sound, until he saw a rock hit a nearby building, bounce off, and roll into the grass. The judge picked the rock up and contacted Yale University, who sent out two very skeptical scientists who fully expected to debunk the whole claim. It can't be rocks falling from the sky, really. Their skepticism didn't last long when they got a good look at the rocks, which were unlike anything they had ever seen in geology. In fact, locals in Weston were digging other stones from the fall out of craters, and eventually that persuaded the two professors that rocks do indeed fall from the sky. Reportedly, this was not enough for then U.S. President Thomas Jefferson, also a scientist. His assessment of the whole thing was reportedly, "Gentlemen, I would rather believe that two Yankee professors would lie than believe stones fall from heaven." Whether he actually said that is still debated, but they do in fact fall from the skies. While in modern times it's fully established that rocks originating from the solar system's asteroids and comets do fall on Earth, they've revealed much about the formation of the solar system, and some of them, particularly cometary material, can be extremely pristine and present a record of the very earliest days of the debris disk that surrounded the young sun and the planets condensed from. But there's a rather interesting component to that. Very ancient comet-linked meteorites known as carbonaceous chondrites have actually shown the presence of interstellar material that predates our solar system. Hidden within these meteorites, specifically in objects called chondrules, which represent the droplets in a sense of what the solar system formed out of, are hidden grains that can be isotopically shown are not from this solar system, and indeed formed in supernovae and stars before the sun ever even existed. These represent the earliest material we have samples of, and indeed can still be captured in space passing through the solar system. Anytime you try to collect material in space, you get a few grains of what appear to be interstellar dust, though it's been proven extremely difficult to establish as to which ones are actually interstellar. By the 20th century, the idea of much larger interstellar objects had been advanced. There was simply no reason that star systems should not kick out asteroids and comets, actually quite a lot of them, to wander the galaxy or enter other star systems entirely. In 1980, an object known as C1980E1 was seen to be gravitationally bound to the Sun, thus from our solar system. That was until it passed too close to Jupiter and was effectively flung out at escape velocity. It is now heading for interstellar space, so if Jupiter can toss material out, so can other star systems. It was suspected that some portion of interstellar objects would most likely be seen as passing asteroids and comets, on trajectories too fast to be gravitationally bound to the Sun. They should just cook on through the solar system and occasionally be detectable. So the suspicion was there, but in recent years, however, we've started seeing them in the act. One of these is the now very famous object Oumuamua, more on that in a bit. But not long after the discovery of Oumuamua, another interstellar interloper was spotted. Known as Comet Borisov, it was definitely on an interstellar trajectory, making it a rogue exocomet. Rogue planets or rogue comets or asteroids, for that matter, can either be objects that were kicked out of star systems at some point, but could also be objects that formed and are native to the interstellar medium itself. You may not need a protoplanetary disk around a star per se for a planet or brown dwarf to form. Borisov, however, probably started out in some other star's Oort cloud. Discovered in 2019 by Gennady Borisov, this particular object is chiefly known for having been so mundane. Other than its speed, it was very much like a run-of-the-mill solar system comet. But it sort of got a bad name for being so normal compared to Oumuamua, when in fact it was actually quite interesting and exotic in its own right. Borisov had a rather large but not very prominent comet's tail that formed as it neared the Sun. At its widest, about 14 times the size of Earth, though the actual object itself, the nucleus, was quite small, probably significantly less than 20 kilometers in diameter. There's evidence that this comet's close encounter with the Sun caused significant periods of fragmentation. It's now a war-torn object after its encounter with the Sun, but it didn't pass all that close to Earth, which prevented us from making a general map of it with radar. Its composition, so far as could be determined, was unusual, but not unlike some solar system comets, in that it was depleted in water and diatomic carbon, but rich in carbon dioxide, probably making it related to a so-called blue comet, where cold chemistry favors the formation of CO2. It did have a weird nickel emission from some unknown volatile compound of that element, which is not well understood, but it seemed to show a normal nickel-iron ratio, which looked like the solar system does. More on nickel in a bit, however. Borisov is now on its way out of the solar system and will take about 9,000 years to cover a light year's distance from the Sun, meaning that in the great expanse of things, we might someday be able to send a probe to catch up with it. but only just marginally so with current equipment. But it seems unlikely we ever will, due to firstly the apparent somewhat mundane nature of the object, but also in that we will probably see a lot of rogue comets like this in coming years as new instrumentation comes online. The numbers are staggering here. Now that we have some indicators to come up with numbers of interstellar objects, it comes out, to our knowledge right now, to the tune of 10,000 interstellar objects on any given day passing within the orbit of Neptune. I repeat, on any given day. With those numbers, there surely must be interstellar meteorites sitting on Earth, and very possibly still sitting unrecognized in our meteorite collections. And in a sense, the suspicion is growing. Anomalous, weird meteorites do indeed exist, and this shows us just how little we actually know about space rocks. In 1938, a meteorite fell in Ivuna, Tanzania. There was somewhat of an early kerfuffle in this one, in that in 1961, researchers Bartholomew Nagy and George Klaus reported evidence of microfossils in this meteorite, and a group of 3 others. It didn't pan out on further scrutiny, but it does represent a far earlier example of claims of fossilized microbial life in meteorites, before the infamous NASA announcement of the possibility in Martian meteorites in the 1990s, also in dispute. But what was found was that Ivuna, a type of meteorite known as a Cl1 carbonaceous chondrite, was likely to be cometary material as far as origins, a class where only 9 known examples in meteorites exist right now, and the amino acids glycine and beta-alanine were found within it. These are not necessarily of biological origin, rather they are the building blocks of it. But here's an even weirder one in the same class as Ivuna, Cl1. A meteorite fell in the town of Orgueil in France in 1864 that at the time was noted could be cut with a knife and be used in place of a pencil for writing. Very quickly for the time, organic materials were found in the meteorite, which actually prompted a really interesting experiment. Louis Pasteur, of much scientific fame, learned of the existence of this meteorite fall very early and wondered exactly what was going on with it, precipitating what might very well be the first search for alien microbes in history. Pasteur had a drill that was sterile, or so he hoped, and could be used to drill into the interior of one of the fragments. If he could get a pristine sample, he again hoped, he could look for alien microbes. But it was Louis Pasteur, and he knew how pesky microbial contamination could be. He actually was successful in hindsight, in that he found nothing. A null result is still useful. And we still have pieces of this meteorite, and there's no indication of microbial life within it. But there were claims. In 1961, a claim was made for the detection of paraffinoid hydrocarbons in this meteorite, a substance which isn't unlike butter. Again, this was met with much skepticism, and the researchers involved more or less abandoned the claim as time went on. But here's the kicker. Some of the samples of the Cl1 carbonaceous chondrites, even though they are apparently very pristine, contain none of the chondrules that characterize these types of meteorites in slightly different classes. The very thing that characterizes stone meteorites in the solar system and even classifies them can be totally absent in these meteorites. That may suggest very high levels of alteration in comets, meaning the chondrules basically dissolved into clays. But how and under what conditions? If it was something going on in the solar system, it didn't happen often. Might these meteorites be in misinterpreted material from some other very different star systems, with very different circumstances than our own? Open questions. Even more interesting perhaps was the 2004 finding again in the Orgueil meteorite that showed freshly fractured surfaces of the meteorite that showed structures that mimic somewhat closely organic mats formed by simple life on Earth. This has also been suggested for features seen from Mars rovers in the Martian landscape. In this case of the meteorite, if that's what these are, then they suggest liquid water exposed to sunlight. Well, naturally, the question was, had the meteorite been underwater or otherwise contaminated here on Earth? If so, this might be explainable, but it wasn't. It had a known provenance since the fall and was never wet. Take it as you will, but it does go to show that we don't really know as much about our meteorite collections as you might think, and how some really anomalous ones came to be, at least enough to rule out that some portion of them are of interstellar origin, or alternatively that there were things going on in the solar system early on that we aren't fully aware of, that may not easily fit our models. As far as interstellar objects in space, much stranger was Oumuamua, which we still don't fully understand. Oumuamua didn't really look like anything we'd ever seen before in the solar system, at least in some ways, leading to the Pan-STARRS scientists that discovered it noting in the paper announcing its discovery that they couldn't rule out an artificial origin, which was later very much expanded on by Avi Loeb. But that idea didn't originate with him. It was certainly a weird object, especially for being the first interstellar object known at the time. But here I have to stress that there is a difference between not being able to rule out an artificial origin for something and actually proving that. We would actually need to catch up with the object and get a close look to know for sure. But my own feelings on this is that it probably wasn't a technosignature, just some kind of asteroid that we don't have a clear analog of yet. But it's not physically impossible for it to have been an artificial object of interstellar origin, any more than someone finding Voyager 1 or 2 in a million years would rule it out as just a weird metallic asteroid. That sometimes gets overstated, that it's highly unlikely we would ever see a piece of alien technology passing through the solar system. Well, how do we know what the likelihoods actually are? The truth is, we don't. We just like to say the word highly unlikely, even though we ourselves send out interstellar objects in the form of dead probes. The chances of anyone finding those is a hugely tall order, but if we keep sending them out for the next 40 million years, then it might not be such a stretch. But at the same time, we spotted Oumuamua at the earliest possible time we technologically could. So you have to ask, how often are you going to encounter a piece of alien technology passing through the solar system solely by chance and the luck of the draw? Probably not often. And it probably won't be the very first thing you see of interstellar origin, where you'd see technology littering all the planets of the solar system, including Earth. You'd be finding metals in archaeological sites and paleontological strata, and there is no good evidence for that. Worth noting, however, that solar system meteorites are found this way in both contexts. Meteorite metal was used extensively in human prehistory, and indeed still is. Modern meteorite jewelry is a thing. But also fossilized meteorites are found, where you see the structure of a meteorite in the paleontological record, but most of its mineralogy has been replaced through the same process that dinosaur bones become fossilized. You don't, however, see all the right angles and traces of machinery of alien origin, at least so far. So a technological origin for Oumuamua isn't impossible, but if that's what it was, it happened under very unusual, deliberate circumstances. It seems more likely that it was a weird asteroid that we might not have enough data on to really start drawing sweeping conclusions. That said, there's been at least some problem physically with every natural explanation advanced thus far, and it has to be said those explanations were reaching further and further out there. From fractal dust bunnies that are unclear how they could survive the interstellar medium, to hydrogen icebergs forming in cold hydrogen clouds that we've never seen even the slightest evidence in nature that such things exist. Pick your poison here, a host of objects we hypothesized could exist, and were thought of specifically to try to identify this object, or it was an alien civilization's trash that we self-prove can happen. We've littered the solar system with our defunct technology, and we remain the one species in the universe that we know for sure that crashes flying saucers onto other planets, such as this one on Mars, which is the discarded backshell from a rover. At the same time, though, it's quite alright to advance an alien hypothesis. Oumuamua wasn't the first time that's happened in science, and it won't be the last. There were once canals on Mars, pulsars were jokingly attributed to little green men, purported fossils in Martian meteorites that turned out dubious, alien megastructures around Tabby's star, and so on. The problem is when you invoke aliens, since you know nothing about their capabilities, they can do anything. And that allows for a catch-all explanation that's more often than not going to be wrong. It's never aliens until it is the usual mantra from science here. Yet on the other hand, all you need is one. Find one alien civilization through SETI or other means, and then it becomes a much more mainstream hypothesis. And objects like Oumuamua go from very unlikely to be aliens to aliens are the simplest answer. But until the Great Silence ends, one must maintain a healthy level of caution. This also applies to UFOs. Until you identify them, they could be anything, and they could get really mysterious if solid evidence is ever presented. Say the US government totes out a recovered piece of technology of unknown origin. So the scientists go in and start doing metallurgical testing and find out that it's not of interstellar origin, but not likely to be human either. Imagine that scenario. But none of this applies to interstellar objects in general. At this point, there's plenty of evidence that they exist, and it's very likely that we have ready samples in the solar system to study, even without having to catch up to one with a probe. This takes us to the potential for captured interstellar objects. Jupiter is a giant elephant in the room that can conceivably capture interstellar objects and hold them in the solar system under the right circumstances. There are at least two candidates for this. Objects that might once have been rogue comets that were captured and put into solar orbit by Jupiter. These are comets Machholz 1 and Hyakutake that, like Borisov, have atypical makeups for solar system comets and might once have been interstellar in origin. There's also the possibility that the Oort cloud contains objects captured either from one of the Sun's siblings in its birth cluster early on, or alternatively objects loosely exchanged with passing star systems in one of the Sun's many encounters with other stars. Actually identifying those is a tall order, however. Visiting Oort cloud objects is still a tough one for our technology, but in the future there may be many interstellar objects identified in the far outer solar system. Again though, the rules change dramatically with the first unambiguous detection of alien life, microbial or otherwise. Once you see it, just once is all that's needed, and explanations invoking life go from highly unlikely to the simplest explanation on a case-by-case basis, opening us up for already having detected alien life without recognizing it. It's even possible that we have already detected alien life from another star system entirely. We just aren't recognizing it as such, or at least not able to prove it. So as far as captured interstellar objects in general, here are the candidates so far, and the speeds that suggest they might be interstellar objects passing through. The first is a weak one, Comet Ison from 2012. Its velocity was only barely potentially hyperbolic, so it's not a good candidate. Rather, it's probably an Oort cloud object that got some kind of extra nudge. It's moving at about 0.04 astronomical units per year, whereas the very human Voyager 1 does 3.57 AU per year. But that's where it gets interesting. Voyager is among the fastest things humanity has ever sent out, yet Oumuamua owns it, doing 5.55 AU per year, with Borisov even faster than that. Another suspect is 2015 BZ509, popularly known as BZ, but also has an official Hawaiian name designation that exceeds my own pronunciation skills. This actually may be a very old captured asteroid based on its orbital characteristics, captured sometime around when the Sun was only about 100 million years old. This object is in an orbital resonance with Jupiter, but actually moves in the opposite direction. Oddly, it's been suggested that BZ might not be an interstellar capture, but was perturbed from the Oort cloud early on, and acquired its retrograde orbit through interactions with the still unconfirmed Planet 9. Either way, this is one mysterious object that might present an attractive target for exploration. And that brings us to the Galileo project's recent expedition to recover meteorite from a bolide, reportedly moving at interstellar velocities that hit Earth in 2014, known as IM-1. The speed of entry of this object, on the one hand, has been criticized as unreliable due to the nature of it having been detected by a network of spy satellites. Disputed, however, with a confirmation from the US government saying it was moving at that velocity with high confidence. But when dealing with instruments that have classified capabilities, there will always be questions. However, there was also supporting evidence obtained from the Manus Island seismic station that further constrained at least the fall area of the object. Within this projected impact area, metallic spherules were found that may represent ablation droplets from the meteorite. This is also in question, in that iron spherules from random meteorites have been detected on the ocean floor, actually over a century ago. But that doesn't really speak to the distribution of this, in that the Galileo project sweeped control areas and found no spherules. The sampling from within the search area is good. Right now the count is up to 360 spherules. The problem, however, is that initial analysis seems to show no nickel, and an abnormal isotope ratio indicating an age around as old as the universe itself. This is at odds with meteorite evidence. Whenever you have iron, you have nickel because that's how those elements are formed. And the age is from a time where it seems unlikely that any materials, other than the lightest elements, should have existed in any quantity in nature. Only time and more research will help resolve the nature of these spherules. And lastly, here I have to add something that just broke at the time of making this video. There is a seemingly unlikely update on Oumuamua that may lead this story into very different territory indeed. In a paper by Adam Hibbard, link in the description below, he details another potential detection of the entry of an interstellar object in Earth's atmosphere. This one fell over Bolivia in 2019 and does not have enough of a data set to really determine its entry speed, which is crucial in determining whether an object could be interstellar in origin. It would normally be discounted as a regular meteorite and garner little attention. The strange thing about this object, however, is that it arrived right at the time that any materials associated with or were once part of Oumuamua should arrive at Earth. It had been suggested that Oumuamua's rather wild tumbling might indicate a past impact. But if that impact were more recent, say within its time in the solar system, pieces might have been knocked off and sent in Earth's direction, which Oumuamua did make a relatively close pass to. It also correlates roughly with the time and predicted direction of such an object. Unfortunately, the data may never be enough for a search for this object, nor is anything known about its size. There may be nothing left to look for, but it does add an interesting chapter to the story of this object, a story that may yet have further chapters. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently profoundly uncomfortable with the idea of other star systems throwing rocks at us in very large numbers. They may in turn be equally uncomfortable with the sun doing it. Not a good stage setting for first contact. And be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.